Hey, and welcome, folks, to Advent of Code 2022, Day 4. So, the astute among you will notice that I've had a haircut and a beard trim. I'm looking fresh to death. But yeah, that's not what we're here for. We're here for coding puzzles. So, let's jump straight in, have a look at today's coding puzzle. Day 4, Camp Cleanup. So, for this puzzle, the elves are cleaning up the camp, and for this, they've split up the camp into ID numbers, and they've assigned a range of these to each elf to clean up. They've done this in pairs, and what they found is that there's some overlapping pairs. So some of the elves have been told to clean up a certain range of ID numbered sections of the camp, and some have been told to clean up another range, and sometimes they're overlapping. So for our puzzle input, we've got this list here. So each one of these lines corresponds to the areas of the camp that one elf has to clean up. So this pair of elves have to clean up the range from 2 to 4, and the range from 6 to 8, so on and so forth. So your first task is to figure out if one range is fully contained within the other, basically. So if we scroll down to their little graphical thing here, we can see that this range here, the 3, 4, 5, 6, 7, is fully contained in the range 2, 3, 4, 5, 6, 7, 8. And that's this input 2, 8, 3, 7, which you can see is up here, 2, 8, 3, 7. So yeah, that's it. It's basically a simple exercise of counting where they overlap. So let's have a look at my code. So first section, let's see. And it runs quite quickly. That's that. Now, this code is it's really quite simple. It's very, very basic, and there's not a huge amount going on here. You could probably do this in, next to a one-liner if you really were so inclined, but this is how it occurred to me to do it first. So getting into it, what are we doing? We have a counter initialized to 0, which will be our output. We start with our file reading loop. We take that input, we're going to split it up here, so I'm just doing some string splitting operations and a map with another split in it, which will just give me nicely indexable inputs which I have labeled here. Then I've decided that I want to turn each of those ranges into an array that contains each point along it. So if my input was 2-4, I want that to become an array that contains 2, 3, 4, and so on like that. So this splat operator working on a range does that. So this will give me my array for my first elf, and this will give me my array for my second elf. So with those two arrays, it's fairly easy to then figure out the first part. So the first bit of logic is they want to know is one fully contained within the other. So the way I thought to do this was, if you do an intersection operation between the two arrays, you can then tell if one is fully contained in the other, because the output of that intersection will fully equal one of the arrays or the other. So in this case, if section 1 was, say, fully contained section 2, when you do this intersection operation, what gets outputted as the intersection will be the entire array of section 2. So you can do a check down here, conditional check down here, to see, does the intersection equal section 1 or does the intersection equal section 2? If either of those are true, then one fully contains the other, and you increment the counter. That's it. It's really, really simple. Yeah, so I don't really have anything more to say about that. It's quite straightforward. Again, this is another one where I did this for section 1, just threw it together and was like, oh, I don't know if I've done something smart or not here. I don't know if I'll be able to reuse this for section 2. And it turns out you can, because they don't really dial up the complexity at all, really, for section 2. They actually just change the problem statement slightly, but it's basically the exact same problem they ask you for section 2. So if we look at section 2 then, section 2, they're saying that even if with that full intersections, there's still quite a bit of overlaps. So what they want to know now is, does any section overlap at all? And the difference here is basically it's a special casing, or the first section is a special case of the second section. So they want to know about overlaps, but in the first case, they only wanted to know if they're fully contained in an overlap. Now they don't care if they're fully contained, they just want to know is there any overlap whatsoever between them. And then they want the count of those. And that's actually an easier logical statement to figure out. And the way we do that, let's see, we go to our second solution. It's almost the same code. Oh, there's the cat back. Hello. I got a little bit of a fart there. Anyway, it's almost the second section. It's almost the exact same as the first section, except that the condition down here is a little bit different. We do our intersection, but in this case, to know if there's any overlap whatsoever, you just do the intersection and then check is the output array empty or not. So if it's empty, there's no overlap of the two sections at all. And if it's got anything in it, then there is. So you just add in an empty check to that array and then increment your counter. And that is it. And that section also runs. There we go. Also quite quick. So yeah, that's it for today. Day 4 in the book. So day 4 done. I thought today was pretty straightforward. I don't really have a huge amount to say about it. Yeah, just messing around with some arrays, figuring out some intersections. I'd love to see if I'm trying to think of like a really clever way to do this. But yeah, I think this is, it was a fairly straightforward problem. Took writing very little code, and yeah, conceptually wasn't too difficult either. So yeah, that's it for day 4. Hope you guys are having fun. I'm still having fun. Me and Kimchi are still hanging out in the office, doing our coding problems. I have a sick new haircut. I'll see you all tomorrow.